Now, moving on to our second winner for the same category, actually. So we have another FNR winner for outstanding PhD thesis, and this goes to Maciej Chrzanowski. Now, we spent a while trying to teach me how to pronounce his name yesterday. He's Polish, and he's done his PhD between the University of Luxembourg and ArcelorMittal. His PhD thesis was based on composite columns used in the construction of tall buildings, entitled Shear Transfer in Heavy Steel Concrete Composite Columns with Multiple Encased Steel Profiles. So his thesis analyzed the structural behavior of a particular type of heavy composite column that forms the backbone of our modern high-rise buildings. And he also proposed an innovative engineering model and a new type of shear connector that can help to improve the safety and cost efficiency of tall building constructions. So reasons why the jury selected you, Maciej, is, for example, one of the strongest points that emerges whilst reading this thesis is the consistency in the design of the experimental activity. The PhD project has been developed in a significantly international scientific environment characterized by collaborations with several researchers active in Europe in the subject of the thesis, and the collaboration with the R&D department of one of the most important steel makers, which will certainly magnify the impact of this research and offer a fast track to the field application. So let's take a look at your work, Maciej.
My name is Maciej Chrzanowski. I am a construction engineer at ArcelorMittal Stelligence, and I have done my PhD at the University of Luxembourg in collaboration with ArcelorMittal. I am happy to receive an FNR award for outstanding PhD thesis for my research on a composite columns with multiple encased steel profiles used to construct tall buildings. In our modern world, population numbers keep growing and the space to construct a new building stays stable. This pushes our cities to grow vertically and construct taller buildings where we could live and work in. When engineering tall buildings, it's important to consider the safety aspect using columns that can support the weight of the construction and act as the backbone of the entire building. But also it's important to consider sustainability to guarantee the optimal use of building materials. However, in past years, the use of regular columns in civil engineering for tall buildings did not really evolve. This led to the limitation on the size of the building, or use big section elements which risk wasting important construction materials. My research provides a way to properly assess the structural behavior of novel but less studied heavy composite columns with multiple encased steel profiles. In our labs, we construct a smaller specimen of columns that were constructed just in the way like the bigger columns used in tall buildings, which was already a challenge. To see which complex composition and connection in steel and concrete was the best in terms of force transfer and stability, we pressed these specimens with the hydraulic press while the specimens were connected to different types of sensors. These smaller columns were used to study the locally acting shear forces, meaning movement between steel and concrete within the column. With this, we want to analyze the mechanical connectors between both materials. In the second phase, we move to the analysis of the global transfer of forces, which is visible, for example, when we bend the larger entire column. Imagine this bend is such a column. Inside a tall building, among all acting forces, it is mainly compressed under the weight of the entire building. It could buckle and bend, and this is normally considered deformation shape. In my research, we observed that a new deformation shape could lead to certain circumstances which could cause earlier damage of the building, which is also an aspect of a safety. There exist several models that can predict how a column could bend under pressure. However, the most used theory does not consider shear forces, or other theories do not refer properly to the behavior of the tested columns. Therefore, I propose a new innovative engineering model in my thesis, which can assess properly the structural behavior of columns in tall buildings, which can thereby guarantee the stability and sustainability of the entire building. What's more, my model can be easily implemented into the existing simplified design procedure. Additionally, I develop and characterize a new product that can be used in those heavy columns, but also in the regular ones. This novel shoe connector can make the whole construction process faster and safer, but also reduce the cost and manpower needed. My results and novel product are very promising and are currently being developed further. I am very happy to have collaborated with the local industry in Luxembourg for my PhD, and that my research actively contributes to make the buildings of tomorrow safer and more sustainable.
Maciej, lovely to have you with us this evening, and congratulations on this award. Tell us who the lovely lady is next to you, who supported you through all of this work.
Yeah, exactly. All the time. This is my wife, my daughter.
Lovely to have you with him this evening. Maciej, your work, I was discussing with you yesterday that you almost didn't apply for this award.
Exactly. I would say the road trip that I passed was quite surprising, I would say. At the beginning, as you mentioned, Lisa, I haven't thought that I was doing PhD at all. And maybe at this time I could start to saying thank you to all the people who appears on my roadmap. So I really need to start with my former supervisor, Violeta Barcewicz, who really suggested me this road and pushed me a bit towards this, and then I take the opportunity and seem to try, and it worked. So it was really a big turnover in my life, our life. And on the second point, yes, after this decision, I moved to Luxembourg. I joined the research team of Professor Christoph Odenbright, and this is for sure the second person I would really like to say big thank you for the entire support and giving me this chance to do PhD at all. And staying in the topic of the university, for sure I need to mention the entire team that was there around, the team of Professor Odenbright. I would say the input of each person was very, very, very important. As it was also mentioned in the first words from you, my PhD was in collaboration with ArcelorMittal, and there I got also very huge support from everybody, especially from the R&D department, where I really need to thank for the entire support to Renata Obiala and Teodora Bogdan, but also to Professor Olivier Vassart and Nicoletta Popa. I would say I had this pleasure to join even the team of R&D for some time, as it was foreseen in the FNR funding. And I must say this time was really, really inspiring. Let's call it like this. Saying about FNR funding, I would say this is also quite a big milestone in my research, because without this, or maybe in other words, thanks to this, my research was really structured, and we followed the plan, and there was no distractions that maybe we should stay here or go there. No, we had a really clear plan how to proceed, which I am really grateful for the entire support and structurizing my work somehow.
Well, you're very lucky. We've got the head of FNR watching your
Exactly.
every word here. And actually,
so it's really helpful.
his background is physics, and we were having a little chat about another thing you mentioned to me in our conversation, Maciej, which is that you never thought civil engineering could win an award, and we were smiling about this. Mark, have you any words of support?
Well, we're very open-minded in that sense.
Yes, indeed.
Yes.
So you're now the new, role model for all civil engineers.
Exactly. For me, it's like double win, because to be honest, maybe I am too skeptic at the beginning, but I was really not believing that civil engineering topic could really pass through all more spectacular topics like physics or medicine, or everything now is around COVID and all this very important stuff like this. And come on, buildings are just standing. Yeah, but if we look really behind the scenes, it's very complex process that
I have one last quick question for you. Given your research, are there certain buildings that you look at in certain countries that you would not step inside?
Ooh.
Because of safety.
I would say there should be no problem like this for our modern buildings, because we have quite well defined our design procedures, how we should safely design a building. The other point that we have to look on is sustainability, and sometimes when we do not understand something very well, we just go more conservative and just build it more safe or something like this. But here arises a question about optimal use of the material, which is, I would say, quite significant topic nowadays.
Maciej Chrzanowski, congratulations once more from all of us. We wish you both a very wonderful evening ahead. Enjoy the rest of the night.